Good morning, ChemComm. Today is your last day of notes of ChemComm. This is it. This is the last thing we're going to cover, and it shouldn't take too long. Should be out of here pretty quick. Okay? So I will say there will be a quiz on Friday that'll cover kind of these 2 days of heat that we've been talking about. It should be pretty brief because we haven't covered quite very much. All right, but today's a little more math that kind of gets into the Q equals MCAT again, but it changes a couple variables. It's not too difficult, very similar. So let's get started. So what we did on the last time you actually looked at a video was Q equals MCAT, right? And that equation is telling about a temperature conversion within a substance. So like if I was heating up water, it's still water at the beginning and the end. We're just seeing how much heat we're putting into the water. This is a similar equation called the heat of combustion, but now we have a chemical change occurring. So now it's not just that we don't just heat up the wood, we burn it. It changes chemically. And so because of that, we need to know how much heat that substance produces typically when it is burnt. And so we use what we call either a kilojoule per gram, which would be how many joules per gram of that substance we produce, or you could use the molar heat of combustion, which is with this many moles, I will produce this much heat. Okay, so that'd be kilojoules per mole or joules per mole. You do not need to memorize these numbers. You would be given them in the problem, or you would be given them on a chart like this. So these are some common things that we know burn. Propylene, ethane, ethylene, acetylene, methane, hydrogen, carbon monoxide, all of these things burn. And you can see over here to the right, this is how much heat they produce, or kilojoules per mole. I know this is written a little weird, but it's telling us how many kilojoules they produce per mole. Notice the larger molecule produces more heat. It's because there's more bonds to break, which should make sense. Okay, the smaller molecules only have this. Carbon monoxide only has one bond, and guess what? A little heat. So we would give you these numbers. We would obviously not make you remember them. But the heat of combustion simply works like this. Q, the heat produced, is equal to the mass of the object, of the substance, times its heat of combustion. That's it. This is actually shorter than Q equals MCAT. I don't know how you would sound this out. I'm not even going to try. But the idea is it's the same equation. We're just taking out the specific heat and the temperature change. We're trying to figure out how many joules of energy this could produce. Okay, so let's do a problem. Okay, so if you see with this problem, it says how much thermal energy would be produced by burning 12 grams of octane. Notice to the right here we have a chart for the heats of combustion. I will be attaching that to the assignment. These would be known heats of combustion that you would be given. So Q equals mass times the heat of combustion. The mass is 12 grams, and we are dealing with something called octane. Octane's here, C8H18. And look, we're dealing with grams. So you want kilojoules per gram, not mole. So that would be 47.8, if I get it right. You would multiply those together, and you'd get 573.6 kilojoules. So in other words, if you have 12 grams of octane and burn it, this is how much energy or heat you would give off. All right? Same equation. How much energy is in kilojoules is released by completely burning 25 moles. So the same equation, Q equals M times the heat of combustion. But in this equation, instead of mass, we have 25.0 moles. And so our heat of combustion for hexane, we're going to use this number because we're in moles, 4141. But the answer will still be in kilojoules because this is how many kilojoules we produce per mole. So really simple math, not a difficult problem. You can all handle it. It's very similar to Q equals MCAT, but it's got even less variables. Another thing that you can calculate, and these are the last two things, is how much heat it takes for something to change phases. All right, and there's two numbers, and you only have to do this with water. But when water freezes or when water melts, it either takes or uses or gives off energy. All right, and we know the amount of energy that it gives off. When something melts or freezes, or when water melts or freezes, we call this the heat of fusion. And the heat of fusion for water is 333 joules per gram. And you'll notice this equation is very similar. Q is how much heat it takes, time equals mass times the heat of fusion, which if we're dealing with water, which you'll always be dealing with water, is 333 joules per gram. The only trick here is you've got to pay attention. If it's melting, that means it's taking on energy, which means this 333 would be positive. But if it's freezing, that means it's giving off energy, so we'd have to turn this 333 negative. But it's pretty straightforward. We also have the other end of the spectrum. If something is boiling or condensing, for that we have a different number for water, 2259, and we call this the heat of vaporization. When you think of vapor, think gas. Gas is involved. In boiling, we go from liquid to gas, and when something condenses, we go from gas to liquid. So the heat of vaporization number is always going to deal with gas in some way. The heat of fusion number, think fuse together, think solid, is going to deal with solid in some way, and liquid's going to kind of be involved in both. But these equations are pretty straightforward. How many joules are required to boil 25 grams of water? So keyword there is boil. So we type the mass times heat of vaporization. If you don't remember that, just go look in the notes. Boiling is heat of vaporization, and the number we need is 2259. Okay, so Q equals the mass, which is 25 grams, times 2259. The only thing I would check there is that number positive or negative. You can say, well, it's boiling, that means heat's entering, but you can also go back. When something boils, the number should be positive. So we leave it positive, we do the multiplication, and we get how many joules it would take to boil this much water. So you can kind of see how a lot of these equations look very similar to one another. We're just changing them a little bit. So there's three equations for this section. Q equals MCAT when a substance is changing temperature. Heat of combustion when something is burning. Okay, and you'd have to look up the heat of combustion on a chart, and I would include the heats of combustion in as a picture in the question, so that'd kind of tip you off. And then your heats of fusion and heats of vaporization, when something's boiling or when water is boiling or changing phases. And that's it. That's really all I wanted to cover today, and all I wanted to cover in this section. We will have one more kind of quiz over Unit 15 to just kind of say, put a bookend on this section in this school year. Be watching for some extra credit maybe next week to show up to a Zoom meeting. But other than that, we're winding down. Come see me and talk to me if you want to see me do some of these in office hours to kind of walk you through them again a little slower. That's fine. But keep up the good work. Be good to somebody today. We'll see you soon. Bye.